Hey everyone, this is Dr. Walker. This is video 548 on superconductors. This is going to be a very brief conceptual introduction to superconductors, not comprehensive at all. We're not going to look at any equations or work on any problems, but I just thought it was an interesting topic, so I wanted to just briefly introduce it. Superconductors are a class of metals and compounds whose resistance decreases to zero below a certain critical temperature, which we call T sub C. So if we look at this graph here, it's for mercury, and it's showing the resistance as a function of temperature. And we see that above a certain temperature, above about 4.2 Kelvin, the resistance increases approximately linearly with temperature, which is what we expect. But below a certain temperature here, about 4.1 or 4.2 Kelvin, the resistance is essentially zero. So this was discovered back in 1911, and the two major kinds of superconductors are ceramics that do have some higher critical temperatures, and then metals. What is really significant about superconductors, what is really cool, is that once you set up the current, since there's essentially zero resistance, then that current can continue on forever, and you don't have losses due to your resistors heating up. So there are a lot of applications of superconductors. One of them is superconducting magnets, which are used in MRI and, for example, maglev transportation here. But these superconductors allow us to have electromagnets, which are more than 10 times stronger than normal ones, but we'll talk about electromagnets later when we get to magnetism. The problem with superconductors is they do require these really low temperatures, which are very hard to attain. So the search continues for materials that exhibit superconductivity at room temperatures, right? That would have tremendous effects on technology, but that search is still ongoing.